Alright, let's talk about redox reactions. So for redox reactions, we must remember this little mnemonic. Oil rig. And what that mnemonic stands for is oxidation is loss and reduction is gain. And we're talking about electrons. So let me use this example of iron. And it has an atomic number of 26, which means it has what, 26 protons. So 26 protons in the nucleus. Now, if we have 23 electrons, we would have iron with a 3+ charge. Okay. Now, to go from iron 3 to iron 2, what would have to happen? Well, you can draw this little diagram of 26 protons in the nucleus, but now we have 24 electrons there. So to go from iron 3 to iron 2, there would have to be a what? Gain of 1 electron. So I did that example to show you that here we have our what? Oxidation numbers taken directly from our charges. So the oxidation number for iron 3 is +3 or 3+, and iron 2 is +2 or 2+. To go from iron 3 to iron 2, we have a gain of 1 electron. So the oxidation number goes down. So what happens? There is a reduction to go from iron 3 to iron 2. Now for the reverse, to go from iron 2 and to iron 3, oxidation must take place. We must have a loss of 1 electron. So this is oxidation. And this is reduction. And so I did that little quick example to show you. We've already covered this in class. This is a review. What happens when things undergo oxidation and reduction. And you remember our charge, we had that little equation from chapter 3 that said the ion charge is equal to the number of protons minus the number of electrons. We could say IC equals P minus E. So that's where our little charges came from. So let's get down to business and look at some of these chemical equations, also called redox reaction. We will have a loss of electrons by one atom and a gain of electrons by another atom or atoms. So these are called redox reactions. So in order to do that, we must assign oxidation states of each atom in the chemical reaction. So let's get started. From the last video, the last topic, we remembered that what? The oxidation state for an element, an atom in its elemental state, solid magnesium, is 0. The oxidation number of oxygen, diatomic oxygen, is 0 as it appears in nature. Now over here, what do we have? Magnesium oxide solid. You recall from chapter 3 or beginning of chapter 4 that this breaks up into Mg2 plus and O2 minus. So the oxidation number here would be +2 and this would be -2. But you already knew that oxygen would be -2 and magnesium, a group to a metal, would be +2. You already knew that. So the oxidation of this metal, we have magnesium going from a 0 to a +2. The oxidation number goes up. So this is oxidation. Now we have what? Oxygen going from a 0. I'll point to that one. From 0 to a -2. So this is what? This is reduction. The oxidation number goes down. So one characteristic about metals are electrophobic. They like to shed, they like to get rid of electrons, they like to undergo oxidation. Okay, like this iron over here. Non-metals, they're electrophilic. They like to accept, they like to gain electrons, they like to undergo reduction, this oxygen. So that's just one characteristic of metals and non-metals that we talked about in class in great detail. So we have what here? We have magnesium being oxidized. So magnesium, since it's being oxidized, it is the reducing agent. It's the opposite. And oxygen is being reduced, so it is the oxidizing agent. Okay? So what this means is, since magnesium is the reducing agent, it gives up its electrons. Its electrons are taken by oxygen. It loses its electrons to oxygen. It is the reducing agent. It loses its electrons to oxygen. Okay? That's what we mean. So, just keep in mind whichever one undergoes oxidation, it is a reducing agent. Whichever one undergoes reduction, it is the oxidizing agent. Okay, so let me erase this to have more room for our next example. Zinc sulfide plus oxygen gives us zinc sulfate. So you remember from ionic compounds that this could break up into zinc 2 plus S2 minus. So we would have a 2 plus on zinc and a minus 2 on sulfur. Oxygen is elemental state 0. Here, oxygen in this compound would be minus 2. Zinc, is plus 2. And we could solve for sulfur using the same routine we did in the last video. So we can say zinc plus sulfur plus 4 oxygens, oxidation number, is equal to 0. This is a neutral compound, so that's plus 2. The unknown here is sulfur, and we get a minus 8. Just skipping a couple of steps, equals 0. Sulfur is plus 6. You should already know how to do this. Okay, so look what happens. Zinc goes from a plus 2 to plus 2. So there is no change. Sulfur goes from a minus 2 to a plus 6. Where are we at? We're at minus 2 down here, and then we go up to a plus 6. So there is an increase in the oxidation number, so sulfur undergoes oxidation. Sulfur undergoes oxidation. Now look at oxygen. What does oxygen do? Oxygen goes from a 0 to a minus 2. Oxygen is being what? Reduced. The oxidation number goes down. It goes lower. So, since sulfur undergoes oxidation, sulfur is our reducing agent. And since oxygen undergoes reduction, oxygen is our oxidizing agent. Okay? So that's how we determine that. I'm going to erase this to give me a little room for the next problem. Okay. Let's get busy. Let's assign oxidation states. Magnesium solid, oxidation state of 0. Nitrogen gas, oxidation state of 0. Refer back to your rules if you don't understand why. Okay. Now look at this. Magnesium nitride. Recognizing that this is ionic, we could break this up into Mg2 plus N3 minus. So this would be what? Plus 2. This would be what? 3 minus, or minus 3. So magnesium goes from a 0 to a +2. The oxidation number goes up, so it undergoes oxidation. Nitrogen goes from a 0 to a what? -3. The oxidation number goes down. It undergoes reduction. So, magnesium is since it undergoes oxidation, it is our reducing agent. And since nitrogen undergoes reduction, it is our oxidizing agent. Very simple, right? Okay, so let me run through a couple of more quick examples to firm you up. The oxidation number of copper in this elemental state is what? 0. Bromine, 2, Br2, as it is in nature, 0. Copper to bromide, you recognize that this is what? Ionic. You can see Cu2 plus Br minus. This is 2 plus, this is minus. Copper goes from a 0 to a +2. Copper is being oxidized, so it undergoes oxidation. Bromine goes from a 0 to a -1. So the oxidation number of bromine does what? It goes down. So it is undergoing reduction. So since copper is undergoing oxidation, it is the reducing agent. Since bromine is undergoing what? Reduction, it is the oxidizing agent. Okay, so that problem is finished just like that. Let's take a look at the next one. Let's take a look at the next one. Okay, so copper to sulfide, you recognize that this breaks up into Cu2 plus S2 minus. So there's +2, there's -2, hydrogen gas, 0. Copper in this elemental state, solid, no charge, has the same number of protons and electrons. Oxidation state is 0. Hydrogen here is +1. We need to solve for sulfur. So we say sulfur plus 2 hydrogens at a -1 equals 0. So sulfur is equal to a -2, skipping some steps. So -2 here for sulfur. So what do we have? Well, copper goes from a 0 to, back up. Copper goes from a +2 to a 0. This time copper is being reduced. Copper is being reduced. goes from a +2 state to what? 0. Oxidation number goes down. It's being reduced. Now let's look at sulfur. Sulfur goes from a -2 to a -2. No change in oxidation state. What does hydrogen do? Hydrogen goes from a 0 to a +1. Hydrogen is doing what? Is being oxidized. It undergoes oxidation. So I come down here, and since hydrogen is undergoing oxidation, it is the reducing agent. Okay? Now, since copper is being reduced, it is the oxidizing agent. Okay? Now, let's look at the last example. And I chose this one in particular because this is very special. Alright, so let's jump to it. This is ionic, and we know that this is +2, this is -2. CO2, we know that oxygen is a -2 in that molecular compound. Well, what is carbon? Let's solve for carbon. C plus 2 oxygens equals 0. So carbon minus 4 equals 0. So carbon in CO2 has an oxidation state of +4. Even though this is molecular, we treat it as ionic to find the oxidation state. So carbon in this molecule, carbon dioxide, has an oxidation state of +4. And the sum of our charges here would equal 0, so we know carbon is correct. Calcium carbonate, solid. So what would we have? Well, we know this is -2. This is what, a group 2 metal, so it should be +2. So we could say, now write this out so you can get the hang of it. Calcium plus carbon plus 3 oxygens equals 0. So let me substitute. +2 for calcium, plus carbon is our unknown, plus 3 at a -2 equals 0. So we have +2 plus carbon minus 6 equals 0. So the oxidation state of carbon would be a +4. So +4. And so we can double check. 3 times a -2 is -6. +4 is -2. +2 is 0. So the overall charge is 0, and it adds up to our oxidation states for each atom. So let's look at this. Calcium goes from a +2 to a +2. So there's no change in oxidation states for calcium. What happens to oxygen? It goes from a -2 to a what? -2. No change in oxidation states. What about carbon? It goes from a +4 to a +4. No change. No change. Just like going to Walmart with $100 bill, you buy 2 items. You give your $100 to the cashier and you get what? No change for 2 items. So we have no change in oxidation states for all 3 atoms. So this is what? Not a redox reaction. This is not a redox reaction. Okay? Now, let's come up here. For homework, this is part 2. Part 2, chapter 4. Your homework assignment is number 95 and number 96. Okay? And this is on page 189.